Hey, good morning, afternoon, or evening, depending on what the time of day you're watching. Okay, we're into today our third day in the first unit of Pre-Cal 20. So let me just set this up here. This is day 3. And we're going to be looking at today solving word problems in the series and sequence 1.2 section. So second day in 1.2. So today is working with word problems. Excuse me for a sec, I gotta answer this. So I'll just put this on pause. Okay, sorry about that. Okay, working with word problems in arithmetic series or sequence. That's what we're going to focus on today. So basically today, I'm going to do 3 different examples. We'll do 3 examples of using the series and sequence work, and then we'll do some practice. Okay, so it should be about 30 minutes of instruction or so, video-wise. And then you can work on some practice. Okay, so let us start by writing out the formulas that we will be working through or be using before we start so that we have something to look at when we're working. So, okay, we have the Tn, this Tn equals T1 plus D times n minus 1. That's the general term formula for a sequence. Could be a series as well. And then we have the sum formula that Gauss developed, where we have n over 2 times T1 plus Tn. Okay, and then we have the expanded sum formula, where if we sub this one into here, we get n over 2 times 2 T1s plus D times n minus 1. Okay, so there's the 3 formulas that we're going to be working with in our practice examples today. And I've got 3 examples over here on the side that we'll work through today. And once we work through those, then we'll do 3 or 4 practice ones, and it'll be in the same section. This is still in 1.2. It's just their second day of it. So let's start off with a real simple example here. So let me paste it in here for you. Let's go with a different color here. Let's go with this. Now let's go green here, I guess. Okay, so hit the green there. That should be good. Okay, so here's the first example. Okay, so let's get that at the top here. Okay, we'll still be using these equations here. So example 1, in a grocery store, cans of soup are stacked in a triangular display. There are 4 cans in the top row and 20 cans in the bottom row. How many cans are there in the display if there are 17 rows in the display? So basically you have to kind of think, okay, well, top row has so many, bottom row has so many, and we want to find out how many total cans are in this. Okay, so we could draw it out or whatever, but let's just define what we know from our written equations here or our word problem. So let's get to the marker here. Okay, so the first thing, there are 4 cans in the top row. So if we call that the first term, T1, the top row will be our first value. There's 4 cans in the top row. Second row, third row, fourth row, and so forth. Okay? And then we think to ourselves, okay, well, it says and 20 cans in the bottom row. So 20 cans in the bottom row is the 17th row. It says How many cans are in the display if there are 17 rows? So we know that T17 is 20. Okay, so we have the final and the initial and the number of rows, which is 17. So that's what we know. And we are trying to find how many total cans do we have. So that's the sum of the series. Put a question mark there. So if we look at our equations in top here, we can get away with using this one right here. Right? Let's undo that. Okay, this one right there. Because we have the final, we have the initial, we have the number of rows. You don't have to know anything about how the rows are stacked or changing because we don't need it in this particular case. Okay, so let's just plug in our values. So if we go S17, the total sum in the 17 rows is going to be using this equation. We'll write it out first. Okay, and then we'll plug our numbers in. So we have 17 over 2 times 4 plus 20. Okay, so we do some simplification. 17 over 2 times 24. So if we reduce the 24 to a 12 by going 24 divided by 2, 12 times 17, that's going to give us our final total sum. 12 times 17, that's 204 cans total. Okay, just a single application of one of the formulas. But being able to recognize what each of these particular numbers in the problem means is the important factor for us. Okay, and that's our first example. Let me just get my timer on so I know how we're doing in terms of time. I don't want to go too far today. So that takes about 7 minutes. That's our first example. Very simple example. Okay, let me take a look through my notes here. In my second example, this one is one of those simultaneous solving questions. So a much more difficult example coming up in our second one here. So the next one that we're going to be looking at is one in which we're going to have two missing variables. So we have two different equations, and we're going to be doing one of those solves. Okay, so let me do that completely on the second page here, and I'll cut and paste it in here for us. Okay, so that we can use it. Okay, so let's go back to our typing here. And I think we used green, so we'll use green again for the question. I guess I should click there first. There we go. Okay, so example 2, paste it in here. All right, so this should be subscripted. So let's do that so that it looks a little bit better. There we are. Okay, it says example 2. The sum of the first 9 terms of an arithmetic series is 162. The sum of the first 12 terms is 288. Determine the first 5 terms of the series. Hint, you're going to need to know T1 and D. And the second hint that I have here is that this is going to require 2 equations. So we're going to have to do S9, the sum of 9, and the sum of 12. So we're going to have to write out an equation for S9, and we're going to have to write an equation out for S12. We know that they're 162 and 288. And we're going to have to write them out in terms of T1 and D. So we're going to be using that second formula, the one that has D, because in order to write the first 5 terms, we have to know what the first term is, right? And then we have to know what the common difference is so that we can keep on adding to it to get those 5 terms. So that's what we need to know. So the first thing we're going to do is we're going to write out what we know first. So get my marker out here using a different color again. Okay, so I know that S9 is equal to 162. Okay, so if I were to write that out, S9 is equal to N over 2 and we'll plug in the stuff that we know right away, times t, 2t1 plus d times n minus 1, close it. So now what we're going to do is we're going to put in the 162 and the 9, and we're going to leave the t1 and d blank. So let's go ahead and put the 9 in. So this is actually 162, and this is going to be equal to 9 over 2, and we don't know what 2t1 is going to be. We don't know what d is going to be, but we know what n is, 9 minus 1, which is 8. So this is going to be 8 times d, so 8 d's. Okay, and we want to simplify this a little bit out here by multiplying it out. So 9 over 2, you can do that as a decimal if you like and multiply it out. So this is going to end up being 162. 9 times 2 is 18 t1 over 2, which is 9 t1s. Okay, and then if we go 8 times 9, d, that's 72, and we divide that by 2, that's going to give us 36d. So we have one equation from this with a blank t1 and a blank d. So we'll call that equation A. Okay, but we have to develop a second equation so that we can, when we have two unknowns, we always have to have two equations to be able to solve it. So we're going to develop a second equation, the T12 one, or sorry, the S12 one. So S12, we know that is supposed to be, I forgot, S12 is 100 or 288. So this is going to be 288. So let's write it in this equation here. Okay, so I'm going to just go straight into writing it like this, and I'll use this as my guideline. So S12 is 288, and that's going to equal 12 over 2 times 2 T1s plus D times 12 minus 1. 12 minus 1 is 11, so that's going to be 11D. Okay, and then we're going to do a little bit of simplification here. This one's easier because this becomes a 6. So this would be 288 is equal to 6 times 2, which would give us 12 T1s. Okay, and then this one's going to be 12 times 11, or in this case, 6 times 11D, because this would be just a 6, right? So that's 66D. Okay, so now we've developed two equations that we can use to try and find T1 and D to get those first 5 terms. So now we have to do solving equations. Okay, 2 equations, grade 9 and 10 work. Okay, we did a little bit in grade 9 and quite a bit in grade 10, solving simultaneous equations. Now, this is not the same as what we did before with where we had T1 and T1 here. So we're going to have to do some multiplications of the equations to eliminate the T1. Like this is a 9, right? And this is a 12. Well, how do you change it into the same equation? Well, you have to multiply them by a certain number. Or you could do the D's as well. So what we want to do now is we want to eliminate the T1. T1s. Okay, so I am going to take equation number, the easiest way to do that is just multiply by the opposites of each of those. So I'm going to multiply this one by 12, because there's a 12 in front of the T1 there, and I'm going to multiply this one by 9, and that's going to give me the same value. So let's go ahead and do that underneath. So let's multiply this top one by 12. I might need the calculator for this one. A little bit rusty on that, doing it in the head. So 162 times 12, that's going to give us 1944. Okay, 9 times 12, T1s, that's 108 T1. Okay, and then finally we have to take 36D times 12. So 36 times 12 That's 432D. Okay, so that's this equation right there, multiplied by 12. Now we're going to multiply this one by 9. So 9 times 288, 288, oops, not 28, pardon me. 288 times 9 is 22,592, pardon me, equals 108 T1 plus, now we're going to take 66 and multiply it by 9. 594D. Okay, so now we have our two equations where these are equal. So we can subtract one from the other. Now you're like, hey, that one's bigger than this one. Shouldn't this be on the bottom? It doesn't matter. We'll just get negative numbers. We'll subtract them. Okay, so 1944 subtracting 2592, that gives us 648 negative. Pardon, I'm going to have to check my phone here fairly soon. So this is 0, okay, because they're even. And then we get 132 subtract, or sorry, not 130, 432 subtract 594. Okay, so that's 162D negative. Okay, and then you just divide that out. Let me pause this again and check that, and I'll just come back and finish that off. Okay, so we're going to divide out now. So we divide out, and we get divide by 162 on both sides, and D is a 4. So now that we know that D is 4, we can find out what T1 is by going back to one of these original equations and finding it. So let's slide this down a little bit and make some more space here. Let's take this equation right here. 288 equals 12 T1 plus 66 times 4. 288 equals 12 T1s, and 66 times 4, that is whatever that is, 144, I think. Subtract it from both sides, and we get, what do we get there? 144. Oh, no, I did that wrong, didn't I? 66 times 4 is not, that's way too, 264. Can't even, 264, can't do that. I knew I was off there. 264. Okay, so subtracting it from both sides. So that would be equaling, if you subtract 264 and subtract 264, we get 24 equals 12 T1. So that means T1 is equal to 2. Okay, so the question then asks us, what are the first 5 terms of this series? So remember, we're adding the terms. 2 is the first one, then we get D is 4, so 4 more is 6, 4 more is 10, 4 more is 14, 4 more is 18. There are our first 5 terms of the series. Okay, so that's pretty much the hard as they get. It's fairly hard, that one. We had to do simultaneous equations, so we had to come up with 2 equations. We had to solve those equations, and we had to solve for 2 variables. So about as hard as they can get. Okay, that takes us close to about 20 minutes. One more example, and then we'll do some practice. Okay, a money one. Let's do this one here. Okay, last example for us today. Example 3. I'll do this on the next page. Okay, and let's copy it in here. Okay, so third example here. A student has a choice of 2 summer jobs that will last 12 weeks. In job A pays $1,350 per month with a monthly raise of $100. Okay, monthly raise, that means after 4 weeks, okay? Job B pays $360 a week with a weekly raise of $5. Which job makes the most money? Okay, so there's a couple ways we can do this. Basically, we're going to compare job A and B. So these are going to both be arithmetic sequences. Now, because we're only dealing with 12 weeks, especially for the first one in months, we could probably write the whole series out and just add it up rather than use formulas if we wanted. And since we've been using formulas mainly, let's do this one a manual way, at least partially anyway. So let's start with this job A situation first. Okay, so if I go job A, okay, first month, okay, $1,350. Okay, then I'm going to get a raise in the next month. So that's going to be $1,450. There's 2 months used up. And the third month, because this is going to last 12 weeks, is going to be 3 months, assuming 4 weeks in a month. That's going to give you another raise of $100. And that's going to give us, not 16, pardon me, $1,450. Now, you could use a formula to take that and figure it out. But this one is pretty easy to sum up manually without having to worry about using a formula in this particular case. So, some total money that you're going to make is going to be the, I put 15, 50. Oops. Let's make sure we do it right. There we go. Okay, that's going to be $4,350 if we add those three up. If she were to do that job A. Okay, now job B, if we set job B up, we're going to be doing weekly changes. So week 1, she starts off with $360. Week 2, she's going to be $365. And then $370 and so forth, all the way up to whatever T12 is. Going to have 12 weeks in there. Well, I am going to do this one in terms of calculating the sum using a formula because I don't want to write that whole thing out. I know that the D is $5, that first term is $360, and that we have our number of terms being 12 weeks. So we know that one of those sum formulas that we can use is if we wanted to find the sum of 12 terms, it would be the number of terms over 2 times 2 T1s plus D times N minus 1. Okay, that's the second formula that we derived. So this is going to be a little bit easier to do if we just use the formula, because this would take a little bit longer to add 12 terms together. But if you didn't want to, you could write this whole thing out and add it up, and that would be fine. So let's go ahead and do that. 12 over 2 times 2 times 360 plus 5 times, okay, and we're looking 12 minus 1 is 11. There we have it. 6 times 720 plus 55. Okay, and let's just bring this down so we can see it a little bit better. Okay, so 55 plus 720, okay, 6 times 775. Okay, 6 times 775. If I were to do that, I would get $4,650. So our employer in job B, and this is job A. So if we want to answer a question, you probably want to make more money. So job B makes more. And what is it? Looks like about $300 more total. Okay, so there's an example. Let's check our time here. There's 3 different word problem examples. Now I'm going to give you some to practice from the second part of section 1.2 with arithmetic series. So practice. So this will be on page 28. Okay, so I've got 4 that you can try. Number 8, number 10, number 11, and 13. Okay, so there we are sitting about 26, 27 minutes. Okay, again, if you have any questions, feel free. That's it for our lesson, just those 3 examples with word problems. And next day, we'll be getting into the geometric sequence, getting into the next section. And like this is probably about a 10 or so day unit, so a couple of weeks long, maybe 2-3 weeks long. Okay, so good luck. I'm going to stop the video there, and if you do have any questions, feel free to get a hold of me, and I'll do my best to answer your questions.